In this video, we're going to learn how to use dictionaries in Python. So dictionaries are a type of data structure which allow us to store data in key value pairs. This can be useful sometimes. So for example, let's imagine that students have a name, an age, and a GPA. We could try to use something like a list, like student is equal to, and then we could have the student's name, and then maybe their age, and then maybe their GPA. The issue with this is that each item is not really described. So we could access the student name with student at the index 0. But really, it would be ideal if we could say student at the index name and then access the student's name, because name is much more descriptive. We can do this kind of thing with dictionaries. So for example, let's define a student dictionary now. We'll have here student is equal to, and we'll have open curly brace and close curly brace. And inside the curly braces, we'll have our first key, name. Then we'll set the key name to the value Grace Hopper. Then we'll have a comma for our next key value pair, and we'll have age set to 22. Then we'll have another key, GPA, set to the value 3.7. So this here is a dictionary. The dictionary stores data in key value pairs. So we could output the dictionary with print and student. And if we save the program and give it a try, we'll get here the dictionary with name Grace Hopper, age 22, and GPA 3.7. Now the length of this dictionary is the number of items in the dictionary. In other words, the number of key value pairs. We could find that using the len function. So here, if we call len and we pass it our dictionary student, this is going to return 3 because we have 3 items in our dictionary. We'll output that using print with print. And if we save the program and give it a try, we'll get 3. Now the type of this object is going to be dict, D-I-C-T. We'll call type and we'll pass it student. And if we output the return value using print and save the program and try it out, we'll get here the type is dict. Now with dictionaries, we can use any immutable type for a key. Tuples can also be used as keys if they contain only strings, numbers, or tuples. Values can be any type. So for example, we could have a dictionary, tribools, and tribools is going to have false as a key, and we'll have a list 1, 2, 3 as a value, and we'll have true as a key and 4, 5, and 6 in a list as a value. And this is valid. We could output tribools with print tribools, and this will work. If we save it and try it, we'll get here the dictionary with false and true as keys and the list 1, 2, 3 and 4, 5, 6 as values. So when we say that we can use immutable types as keys for Python dictionaries, what that means is we can use things like booleans and integers and strings. Those are immutable types in Python, because if you have a string ABC, we can't change that string to ABCD. Doing something like concatenating D to the string ABC would actually create a new string object, whereas lists in Python are what are called a mutable type. So if we have the list 4, 5, and 6, we could append to this list 7, and it would be the same list object, but that list object would now have another item 7. So we can't actually use immutable types as dictionary keys in Python. So for example, we couldn't use a list as a key. Now we can also use the dict function to create a dictionary. So for example, we could have here ada is equal to, and we'll call dict and we'll pass it name is equal to ada. And then we'll have GPA is equal to 3.7. And this function here with these keyword arguments here is going to create a dictionary ada with the keys name and GPA. We could output ada with print ada. And we'll save the program and give it a try. And we do get a dictionary with those keys and values. And notice that the identifiers here, name and GPA, did become strings here with string name as the key here and string GPA as the key here. Now we can also have empty dictionaries. So for example, we could create an empty dictionary with empty dictionary is equal to, and we'll just have an open curly brace and a closed curly brace, and that's it. Then we could output that empty dictionary with print empty dictionary. We could save it and try it out, and we'll get here the empty dictionary. Now we can use the key of a Python dictionary to access the value for that key. So for example, if we have a dictionary course with the keys name, and we'll have average. We'll have name set to Python 101, and we'll have average set to 85.5. We could access the value at the key name with course, and then square brackets, the key name. Then we'll output the result using print, and if we save the program and give it a try, we'll get Python 101 here. Now keys do have to be unique. If, for example, we tried to have another name key here, like name is set to calculus, then if we save the program and try it out, we'll just get calculus here. And that's because we can only have one name key. And when we try to set the name key to something else, it's going to overwrite Python 101. And the key name is now going to be set to the value calculus. Now we'll get an error if we try to access a key that doesn't exist. So for example, this dictionary has no key teacher. So here, if we try to use the key teacher and we try to output the result using print, and we save the program and give it a try, we'll actually get an error here. It says key error, the string teacher. So we can't do this. We can also use the get method to access a value that's associated with a key. So for example, we could have here course.get, and we'll have the string average. This is going to find the value for the key average, and it's going to return it. We could output that using print. So here we'll have print. We'll save the program and try it out. And we do get the average 85.5 here. Now we can also modify the value for a key. So if here we have course and we'll have at the key average is now equal to 90.2, then the key average will now have the value 90.2. And we could see that if we output that value, we could have print and we'll have course at the key average. And if we save this and try it out, we can see the average is now 90.2. Now we can also set new keys to new values in our dictionary. In other words, we can add new key value pairs to our dictionary. We could have here course, and we'll have at the key room number. Then we'll set this equal to 205. This will add a new key value pair to the dictionary with the key room number set to the value 205. We could output this using print and course, and if we save the program and try it out, we can see our dictionary now has a key room number set to the value 205. We can also use the update method to modify values in our dictionary and set new key value pairs. So for example, we could have course.update, and we can pass this method the dictionary containing name set to Python 102, and we'll have another key average set to the value 75.4. What this will do is update the values for the name and average keys in our course dictionary. We could output the dictionary with print and course. Then we'll try it out, and we'll get here that the name key of our dictionary had its value updated from Python 101 to Python 102, and the average key had its value updated from 90.2 to 75.4. Now we could also use the update method to insert new key value pairs into the dictionary. So we could have a new key here, teacher, set to the value Barbara Liskov. So we'll have Barbara Liskov here. Then if we save the program and try it out, we now see we have a teacher key set to the value Barbara Liskov. Now to create a copy of a dictionary, we can't just use the assignment operator. We have to use something like the copy method instead. So for example, if we have here variable is equal to course, this does not create a copy of the course dictionary. We can see this if we try to modify the teacher key of the variable dictionary. So here, if we have variable and we'll have at the key teacher, we'll set the value Fred. Then here, let's try to output course. We'll have print course. So the issue here is that assigning course to variable doesn't create a new dictionary. Instead, variable is what's called a reference variable. Variable is going to reference the same dictionary in memory that course references. So in other words, variable and course are both sort of like labels for the same dictionary in memory. So when we actually access the teacher key of this dictionary that variable is referencing, we're actually modifying the same teacher key value that the course variable is also referring to, because they're both referring to the same dictionary. So here, if we output course, we're going to find that its teacher key value was actually modified by this. So we'll save this and try it out. And we can see the dictionary referenced by course does have its teacher key updated to the value Fred. And that's after using variable to update the value of that key. And the reason why this works is that assigning course to variable does not actually create a new dictionary. Instead, variable is set to reference the same dictionary in memory that course already references. Now to actually make a copy of a dictionary, we can use the copy method. So here we'll have course copy is equal to course.copy. What this will do is return a new dictionary, which is a copy of the same dictionary that course references. So course copy is now going to reference a new separate dictionary, which is a copy of the dictionary that course references. So if we try to modify the course copy teacher key value and set it to Joe, then if we output course here, we'll find that course's teacher key value hasn't been modified. We'll save this and try it out. And the teacher key of course still has the value Fred. And that's because course copy this time is a copy of that dictionary. And what we modified this time was the value of the teacher key for that other copy dictionary. Now we could output the other copy dictionary with print and we'll have course copy this time. And if we do this and save the program and give it a try, we'll see in this dictionary, the teacher key value has been updated to Joe. Now we can loop through the keys of a dictionary using a for loop. So we could have here for key in course. And what this will do is execute the loop body for each key in the dictionary course. And each time the loop body executes, key is going to be set to the next key in that dictionary. We could output the key with print key. If we save this and try it out, we'll get the keys name, average, room number, and teacher, which are the keys of that dictionary. Now we could also use these keys to access the values in the dictionary. So we could have here print key and we'll have comma, and we'll use course at the key to access the value at each key. We'll save this and try this out. And now we'll get name Python 102, average 75.4, room number 205, and teacher Fred. We can also delete key value pairs, in other words, items from a dictionary. So for example, if we have a dictionary school with, let's say, the keys name set to Harvard, and we'll have city set to Cambridge, and we'll have country set to USA. Then we'll set one more key founded to the value 1636. Now, if we open this dictionary with print school and save the program and try it out, we'll see the keys and values of that dictionary. We can use the pop item method to delete the last key value pair that was added to the dictionary. So the last key value pair that was added to the dictionary was this key value pair here with founded set to 1636. We could use here school.popItem, and that will delete that item from the dictionary. We can see this if we output the dictionary again using print, and we'll have school. We'll save this and try it out. And we can see that key value pair has now been removed from the dictionary. We can also use the pop method to remove an item from a dictionary according to a key that we supply. So for example, we could have school.pop, and we'll pass the key city. What this will do is delete the item with the key city from the dictionary. Again, we'll output school using print school so we can see this. We'll save it and try it out. And we can see the item with the key city has now been removed from the dictionary. We can also use a del statement to remove an item from a dictionary. So if we have del, and then we'll have school at the key country, what this will do is delete the item with the key country from the dictionary. We could output the dictionary to see this with print school, and we'll save it and try it out. And now that key value pair has also been removed from the dictionary. Now we can use the clear method to clear the dictionary of all items. So if we have school.clear, what this will do is make the dictionary empty. So we'll have school.clear, and then we'll output the dictionary with print school and save it and try it. And we'll get here the empty dictionary now. Now we can also use a del statement to delete the entire dictionary object. So if we have del and then school, this will actually delete the dictionary object. If we try to print school and save the program and try it out, we'll actually get an error now because school is no longer defined. We can access the keys, values, and items of a dictionary by using the keys, values, and items methods. So for example, if we have a dictionary X with the key A set to 1 and the key B set to 2 and the key C set to 3, we could access the keys of this dictionary with x.keys. And we'll store the return value from calling this method into the variable xkeys. Then we'll output xkeys with print xkeys. And we'll also comment out this line so we don't get an error. Then we'll save the program and try it out. And we can see here we get what looks like a list. It looks like we have a list with A, B, and C in it, which are the keys of our dictionary. Now that is actually a view object. What that means is if the keys of our dictionary change, that view object will actually be updated. We can also access the values and items in the same way. So here we'll have x values is equal to, and we'll have x.values to call the values method, and we'll output these with print with x values. Then we'll also access the items with x_items is equal to x.items, and then we'll output x items with print x items. If we save this and try it out, we'll see we get similar objects here, where this here is what looks like a list containing the values 1, 2, and 3. And here we have what looks like a list containing the tuples with the key value pairs of our dictionary. So these again are also view objects, which are actually going to be updated if the keys and values of our dictionary are modified. So let's create a new item in our dictionary by setting the key D to the value 4. Then we'll output x items, x keys, and x values again. We'll have print and x keys, and then print with x values, and then print with x items. If we save this and try it out, notice how these view objects have been updated. So we have the new key in the dict_keys object, and we have the new value in the dict_values object, and we have this new tuple with the key value pair in the dict_items object. So be aware that we do have this updating behavior with the view objects returned by these methods. Now we can use a for loop to loop through the items of these view objects. So for example, we could use the values method to loop through the values in a dictionary. We could have for value in x.values, where this loop is going to run for each value item in the view object returned by the values method. And each time value is going to be set to the next item in that view object. We could then print that value with print and value. If we save this and try it out, we'll get here 1, 2, 3, 4, which are the values of our dictionary. Now we could also use the items method to access the key value item pair of each item in our dictionary. So we could have for, and we'll have key, comma value in x.items. And this will loop through the key value tuples in the view object returned by items, where key and value are going to be set to the key value pairs of our dictionary. We could output those using print and we'll have key, comma value. If we save this and try it out, now we get the key value pairs A1, B2, C3, and D4. We can use the in operator to check if a key is in a dictionary. So here, if we have if the key D is in the dictionary X, then we'll output here that D is in X. Otherwise, we'll have else, and we'll output D is not in X. Now we do have a key D in our dictionary X. So if we save this and try it out, we'll get here that D is an X. If we check if the key E is an X, here we'll get E is not an X because we have no key E in our dictionary. If we save this and try it out, we do get that E is not in X. Now we can also have what's called a nested dictionary, where at a key, a dictionary has another dictionary as a value. So for example, let's say we have a dictionary math class. And in this dictionary, we'll have a key course set to the value calculus. Then we'll have at the key teacher a dictionary as a value. And this dictionary will have the key name set to the value John Nash. Now to access the values stored at the keys in this nested dictionary here, we can use the syntax. We could have math class at the key teacher. This will give us access to this dictionary here. Then we could access the keys of that dictionary with, let's say, name here. This will then give us the value John Nash. We could output this using print. And if we save it and try it out, we'll get John Nash here. Now the copy method that we used earlier creates what's called a shallow copy of the dictionary object. What that means is that nested dictionaries and other nested objects are not going to actually have copies of them made as part of producing the copy of the dictionary. Let's see the consequences of this. So here, if we have math copy is equal to, and we'll have math class.copy. What this will do is create a shallow copy of this dictionary. The problem is in that new dictionary, the teacher key is going to reference the same dictionary object here in the original dictionary object. And we can see that if we try to change the teacher name. So here we'll have math copy and we'll change the teacher's name to Isaac Newton with is equal to Isaac Newton. Then we'll output the original math class dictionary with print and math class. And if we save this and try it out here, we'll see that the teacher name in that original math class dictionary is now set to Isaac Newton. And what happened here is when we used the copy method to create a copy of that dictionary, it didn't copy the nested dictionary. Instead, the teacher key of this new math copy dictionary actually references the same nested dictionary as in the original math class dictionary. So when we modify that nested dictionary, we're actually modifying the dictionary in both the original math class dictionary and in the copy math copy. So what we could do is use a deep copy to create a copy of not only the dictionary, but the nested dictionary as well. We'll have to import the copy module to do this. So up here, we'll import the copy module with import copy. Then we'll use the deep copy function from that module. Up here, instead of calling the copy method, we'll now have math copy is equal to copy.deepCopy to call that function, and we'll pass it our math class dictionary. This will create a deep copy of the dictionary where that nested dictionary is copied as well. So now if we modify the nested dictionary of that copied dictionary, it's going to modify the copy of that nested dictionary. Then if we output the original dictionary math class and save this and try it out, now the teacher name is still John Nash because modifying the nested dictionary in the copy didn't modify the nested dictionary in the original because a deep copy was made. Now, as of Python 3.7, dictionaries in Python are ordered, and the items are going to be ordered by insertion. So for example, if we have the dictionary M with the key X set to 1 and the key Y set to 2, and we have a dictionary N with the key Y set to 2 and the key X set to 1, even though these dictionaries have the same key value pairs, they're not in the same order. In this dictionary here, we have the key X set to the value 1 first, followed by the key Y set to the value 2. In this dictionary here, the order is reversed. And that order does matter, and it's by insertion. So we could see this if we output the dictionaries M and N. We could have here print, and we'll have M, and we'll have print, and we'll have N. If we save this and try it out, we'll see in those dictionaries the key value pairs are in different orders. Now, this won't matter if we check to see if the dictionaries are equal. So if we have here, if M is equal to N, even though the order of the items is different, the dictionaries are still going to be considered equal. So here, if we have print and then M is equal to N, and save this and try it out, we'll get here that M does equal N. So this is how we can use dictionaries in Python. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers.